Good day, grade 10 learners. Welcome to our mathematics revision lesson. I am Zikhulile Ncube, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, grade 10s, we've done our revision for paper 1. We did functions. Do you remember that? Okay, so today we're going to concentrate mainly on algebra and number patterns. Okay, we've done functions. Okay, so we're going to concentrate on what? On algebra and number patterns. I'll be giving you past examination questions. I'll give you time to try them, and then after that we do it together. Okay, make sure that you have your pen, your book there. Don't just listen and listen to me. You have to work it out. So I'm going to give you time to do your work, and then after that we just do it together. Remember our revision. Okay, we revision, so we are preparing for our examinations. Okay, right, remember that paper 1 is going to be having the 3 topics: functions and graphs. We've done this one, we did it in the previous lessons. So today we're concentrating on algebra and number patterns. Right, and then algebra is how many marks? 30 marks. And then number patterns, 15 marks. So the most part of the lesson is going to be on algebra, and then the last part of the lesson we're going to do what? We're going to do number patterns. Okay, right, so these are some of the common errors that we get in the examinations from learners: not factorizing correctly. Okay, learners failing to what? To factorize. So the examples that I'm giving you, you don't need to cram them because they're not going to come out in the exam as they are. You are learning the concepts. Okay, you are learning the concepts. So I'm going to be emphasizing some of the things there. Okay, incorrectly rounding off, incorrect representation of inequalities. Some learners don't know which one is greater than, which one is less than, or greater than or equals to, or less than or equals to. Okay, use of and or interchangeably when it comes to inequalities. What is the meaning of and? And when it's an interval, and then or when is what? The other one is going the other direction and the other one is going the other direction. I'm going to explain that during the lesson. Right, another one here I want to add under factorizing. Sometimes what we do as learners, we factorize incomplete. We don't do complete factorization. We complete partially. That's a common mistake. Make sure that when you're asked to factorize, you factorize fully. Okay, and then I'll emphasize some of the methods that we use to factorize. Okay, right, when solving simultaneous equations by substitution, avoid creating fractions where possible. What do I mean by that? Right, let's say we have a linear equation which is y is equals to 2x plus let me say 3 minus y here. Okay, is equal to 2x. Let me just do it like that. Now I have to make y the subject because y will not create fractions. Okay, so I can transpose and bring y this side, and then transpose 2x and bring it this side. So remember, when you transpose and the term jumps the equal sign, what happens? It changes sign. So you're going to have 3 minus 2x is equal to y. Do you see that I don't have any fractions there? But if you try to isolate x, you have to divide all the terms by 2. We have 3 over 2 minus half y is equal to x. So you have created fractions there. Avoid this. Create your third equation like this so that it becomes very easy for you to deal with the equations. Okay, right, confusing n and tn is a common mistake when it comes to number patterns, grade 10s. It's a very common mistake. What is the difference? Maybe let me give you 30 seconds. Right, discuss here. What is the difference between n and tn? Just 30 seconds. Let's see. Right, what did you discuss? What is the difference between n and tn? Let's say I have a sequence here which is 8 followed by 5 followed by 2, then followed by what? What will be the next one? 8, 5, 2. What will be the next one? -1. Okay, it can go on like that. You see that this is a sequence, it goes on like that. Okay, so now if I say I pick 5 here, 5 is term number what? Is term number 2, because this is term 1, term 2, term 3, term 4. Okay, let me write T1, T2 like this, T3, T4. You see that? So 5 is term number 2, so n there is 2. And then T5, what am I saying? T2 is 5. You see that there's a difference between n. N is the number of the term in the sequence, the position sort of thing in the sequence. And then Tn is the term itself. Okay, 8 is T1, 5 is T2, 2 is T3, -1 is T4, like that, till you get to your Tn, which is the nth term. Okay, please don't confuse those two. When calculating the common difference, subtract the term on the left from the term on the right. That's a common mistake again. Right, if I say find the common difference of this sequence here, what will learners do? Okay, they will say 8 minus 5, because 8 is bigger than 5. No. You say term 2 minus term 1, term 3 minus term 2, term 4 minus term 3. Okay, not the bigger term minus the smaller term. No. Okay, your difference can be negative, great tens. So you can have 5 minus 8, which is -3. You see that? Term 2 minus term 1. Term 3 minus term 2. Like that. Okay? Right. Remember that. Don't make that mistake of saying bigger term minus smaller term, or term 1 minus term 2. No. Okay? That's a common mistake. Right. I want us to try things. If the question is 2 marks, roughly let's use 2 minutes. When it's 1 mark, we'll roughly use 1 minute. Okay? Right, given Q is equals to B squared minus 4AC, we're given that. Right, determine the value of Q if A is equal to 2, if B is equal to -1, and if C is equal to -4. Leave your answer in the simplest set form. Right, I'm going to give you 1 minute. Like I said, you have to use 2 minutes, but if we do that, we're going to do very few questions. Okay, I want us to do as much as we can. So now 1 minute, can you try to do that? Let's try. Right, welcome back, greetings. Let's do it together. So now we have B, we have 4AC there. What are we supposed to do? We have to what? We have to substitute. Right, okay. So what is B? Where there's B, we put -1. So it's going to be -1 squared. Okay, there are a lot of free marks in mathematics. Okay, everything that we do is a mark. Substituting correctly is a mark. And every time you substitute, put whatever you substitute in the brackets. Okay, and then the root sign, don't write your root sign like that and then ends there. No, it must go on like that, so that everything is beneath it. Right now, and then -4, what is A is 2, and then what is C? -4. Okay, right, you see that, and then you can use your calculator to get that, because we're using our calculators in the exam. But this is like 1 plus 8 times 8, 16 times 2, 32. So this is what? This is actually root 33. They said we must leave our answer in what? As a set. So we're going to leave it like that, root 32. Sorry, root 33, that's the answer. Okay. Right, state whether Q is a rational or irrational. Okay, you can even put your root 33 in your calculator. Just say root 33 and see what you're getting. Root 33 equals, and press SD there. You see 5,744562647 goes on like that. Does it end? The decimals do not end. They're non-terminating decimals. Are they recurring there? Not recurring. Do you see that? 7, 4, 4, 5, 6, 2, 6, 4, 7. We don't even know what the next number is going to be. So it's not recurring. So it's a non-recurring decimal. It's a non-terminating decimal. Therefore, it is irrational. Irrational. That's the opposite of rational. Okay. So Q is rational. The Q is the whole thing here, which is root 33. Okay. Between which two consecutive integers does Q lie? This is a common question for grade 10s. I've never seen a grade 10 paper without this question. So let's try this. This is a free mark. 1 minute. Let's try. Right. Welcome back, grade 10s. Let's see. Right. Root 33. Square root of 33. Right. Let's look at the square numbers. Okay, let's look at the square numbers. We can even write them down. And don't forget, grade 10s, 1 is a square number. So it's going to be 1 squared, which is 1. These are square numbers. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And then 6 squared is 36. We've passed 33. Okay, so what you do now, you're right. 33 is between 25 and 36. So you look at this now. So it means 33 is between 25 and 36. Then what's the next step? This thing is 1 mark now. So you mustn't waste time here. Okay, what's the next step? Okay, square root everything. Okay, and then the square root of 25 is 5. Then root 33 will remain said, and then 6. So it means root 33 is between 5 and 6. Consecutive means that these are integers that follow each other. Okay, let's move on to the next question. Factorize the following expressions fully. Okay, factorize the following expressions fully. Let me give you 2 minutes for 1 to 1, and then after that I will explain 1 to 2. Right, 2 minutes for 1 to 1. Let's try that. Right, welcome back, grade 10s. The question says, factorize. Is it a question or instruction? Instruction says, factorize the following expressions fully. Are we going to factorize fully? We have to. Because like I said, there's a common mistake where learners do not factorize fully, factorize partially. Let's take note of that. We do not factorize partially, we must factorize fully. Right, the instruction itself must guide you. Okay, if you're dealing with polynomials and then you're asked to factorize, you will have to create brackets. You will have to create brackets. And then if you look at this expression here, we have a bracket which is already there. So the chances are high that I have to create a bracket which is the same as this bracket. Do you see that? And then I can factorize that. Now, so how can I create a bracket which is similar to, which is the same as this? I can factor out -1 here in these two terms here, these ones. Okay, so this one is already t squared, and then what? R minus s, and then I factor out -1, write your -1 so that you don't forget. -1 like that, and then, okay, when you're factorizing, you divide your terms by what you factor out. Like here, we're going to divide this -r divided by -1 because we factored out -1, and then it will give us what? R. And then we divide plus s divided by -1. Then we get negative s. You see that? Okay? So we're getting this and this. So inside the bracket, we're going to have r minus s. Now, if you check, we have a common bracket, okay, which we can factorize. We have to factorize that bracket. But some people just say, take the common bracket and take this and this, it forms your second bracket. Yes, fine. That's the shortcut. But now, what you're actually doing there, we are factoring out r minus s. Just like we factored out -1. Same process. So we factor out r minus s. And then in the bracket, we're going to remain with t squared minus 1. You see that? The common bracket gives you the first bracket or the other bracket, and then these two, they give you the second bracket. I think that can assist you a lot in the examinations, okay? But actually, they were factoring out the common bracket. Okay? If you can recognize that, that is very, very good. Right, now, is this our answer? What do you think we must do? Is this our final answer, this one? Is it our final answer? It can't be. We have not fully factorized. So we can't get all the marks if we leave our answer like that. What is this? The difference of two squares. Remember, 1 is a square. So 1 is like 1 squared. And we are subtracting 2 squares. That is difference of 2 squares. And it means r minus s, and then t minus 1, and then t plus 1. Remember that if you're talking about difference of 2 squares, x squared minus y squared is equal to x plus y, okay, and then x minus y. Remember that, okay? Right, now let's go to the to question 1 to 2. I know that people want to try that, okay? You can be ahead of me. You can be ahead of me, isn't it? Right, try to be ahead of me if you really want to try. But if it's giving you problems, please, let's work together. What do you see if you look at what those two, is one term actually, because there's a numerator and denominator, and then they're separated by division line, the division, so it's one term. So the numerator, if you look at the numerator, what do you see? Difference of, sum of what? Sum of 2 cubes. Do you remember that? Sum of 2 cubes. Right, okay. Now, because 1 is a cube, 1 cubed is 1. 1 times 1 times 1 is 1. So 1 is a square number, 1 is a cube. Okay, right. Right now, so it means we can write this one as x cubed plus 1 cubed over x squared minus x plus 1. Now, do you remember how we deal with what? We deal with the sum of two cubes and the difference of two cubes. Do you remember? Let me use x cubed and y cubed just to remind you. Right, okay, let me generalize here. So let's start with x cubed plus y cubed. Okay, right, equals to, I'll write underneath that. Right, no, the first bracket, the bases, the x and y with the sign, they form your first bracket, the bracket which is made up of what? Of two things. Okay, so it's going to be x plus y. You see, if the sign here is plus, the sign here is going to be plus. Okay, just take that, x plus y. And then the second bracket is going to have three terms in it. Right, just know that the first term is going to be this term squared. And then the last term is going to be this one squared, y squared. Okay? And then in the middle there, it is the product of x and y. Okay? In the middle there. See that? Done. Almost done when you get that. Okay? So we have our x plus y formed by the bases here. And then x squared, y squared. And then now, this sign here is always positive. It is always positive. And then this one is always the opposite of this side. So it's going to be negative. So whether it's a sum of two cubes or difference of two cubes, we are going to have two pluses and one minus, or two positives, two plus, I mean this, and then one minus for both. Okay, let's try the difference. So it's x cubed minus y cubed. Remember, I'm using these examples to remind you about the concepts that you're going to find in the exam. Because in the exam, you may not find this expression. You may find x cubed plus what? Plus 8. You see that? So you must understand that. And then now it's going to be x minus y. Remember, the first bracket, you take the bases x and y there and its sign. And then already we have our negative. I said there's one negative and two positives. So it means the next is just the positive because we already have one negative. So it's going to be x squared plus xy plus y squared. Okay, this one is always positive. Okay, this one is the first term squared, the base, and then this one is the second base squared. Like if this one, you square this one, and then you square this one. It gives you this and this. Okay, now let's go back to our question. So now, what is it going to be? The 1 is like the y. So it's going to be x plus 1. You see that? And then x squared. And then 1 squared is what? 1 squared is 1. Okay. In the middle, we've got x times 1. X times 1. So it's going to be x. If you want, you can write 1x. It's still okay. And then we had a plus here. This one is always positive. And then this one is always the opposite of this sign here. Okay, so it's going to be negative. Then you close your bracket like that. Right? Over our numerator, which is x squared minus x plus 1. It's coming out nicely. I can see that. And then x squared minus x plus 1 divided by x squared minus x plus 1 is 1. It does not just disappear. It's 1, becomes 1. If you say 2 divided by 2, you get 1. Don't get a 0. Okay? So remember that. Then we remain with x plus 1. We have simplified our expression by factorization. You see that? Okay. Right. Let's move on to the next one. Simplify by following. What am I saying? Simplify the following completely. Okay. Right. What does simplify mean? And then if I check there, I've got brackets. So what do I do? Simplify. I have to remove the brackets. Okay. Factorize, I have to introduce the brackets. Simplify, I have to remove the brackets. I'm going to give you 1 minute. The question is it's supposed to be around 2 minutes, but because of time and you want to do more things, I'm going to give you 1 minute to try. 1, 3, 1. Let's try. Welcome back, grade 10s. Let's continue with our lesson. Right. There are some basic things that sometimes we're told by our teachers and then we don't follow. Okay, if you don't follow those things and you're doing the right thing, no problem. There's nothing wrong about that. But some things we want to make sure that you don't lose marks unnecessarily. Don't lose marks unnecessarily. Okay, we need these marks. 2 marks is a lot. There's a big difference between 80% and 78%. 78% is level 6. 80% is level 7. Okay, so it's very, very important. Let's make sure that we get all the marks. Right, so this question, make sure that every term in the first bracket multiplies every term in the second bracket. And how can you do that? You can do simple things like drawing your arrows. Do that. Do that so that you don't forget. So it's 2y times 7y squared. 2y times, take your time. Don't rush. Take your time. Right, 2y times 7y squared. I'm also going to take my time because I don't want to make mistakes here. You see, I'm also writing just like you're doing there in the classroom. So I'm not going to make a mistake. Right, if I make a mistake, you tell me. Right, remember our WhatsApp line. I just forgot to remind you about that. 064 748 8913. Please send us your questions, send us your input, and you can send us your work. Right, 2y times 7y squared is 14. Let me write equal sign here. 14y squared. I multiply 2y times this. Take note of the signs. Is 2y times negative 6y. Not times 6. Times negative 6y. So it's negative 12y squared. Okay. Right. And then I have 2y times negative 8. What do I get? Right. Negative 16y. We have multiplied 2y by every term in what? In the second bracket. Now we go to plus 3. Plus 3 times 7y squared is plus 21y squared. And then plus 3 times negative 6y is negative 18y. Okay, right, and then we have positive 3 times negative 8 is what? Negative 24. Right, and then we can collect the like terms, grade 10s. Try to be ahead of me. Right, and then we have this like term. This is a like term. So what is negative 12 plus 21? What is it? It's going to be what? 9, isn't it? 9, yes. 9. So it's going to be 14y squared plus 9. Where do I get y? Okay, I made a mistake here. 2y times 7y squared is 14y cubed. Sorry for that. 14y cubed, not 14y squared. So this is 14y cubed. Okay, please take note of that. 14y cubed. And then 9y squared. Right, and then we have this one, negative 16y minus 18y. What is it? Is negative 34y. And then the last one is negative 24. Okay, do you see that? We have simplified that. Right, let's move on to the next one. The next one, I'm going to explain it, then I'll give you time to try 133. Right, now, what do you see that can give us 1 mark there? A free mark. There's one thing that can give us a free mark there. What is it? Look at this. What is it? Difference of 2 squares. Okay, just doing that. It's a mark. Out of 3, you have a mark there. So it's 3. Okay, let me use another color so that you have different things here. Right, okay. It doesn't want to go out. Okay, it's fine. Right, now it's going to be 3. Right, over. Then this is difference of 2 squares. So it's going to be what? 9 is what? 3 squared, isn't it? So it's going to be x minus 3 then x plus 3, okay? And then plus 2 over x minus 3 squared, okay? Right, x minus 3, remember, is like x minus 3 times x minus 3, okay? So now we want to have an LCD here, the lowest common denominator. What must we do? We must multiply this one by x minus 3 so that we get x minus 3 squared, okay? And then we multiply this one by x plus 3. Let me show you. So we have 3 x minus 3, then x plus 3, okay? And then we multiply it by what? By, right, x minus 3, and then over x minus 3. Do you see that? Then plus, okay, plus. Let me go back to my color that I was using. Let me use plus here. Right, you get what? 2 over x minus 3 squared. Then you multiply by what? By then x plus 3, because we want to have the same denominator, and then x plus 3, like that, okay? Just like with the fractions that we do, we've been doing since what? Since primary, okay? Right, if you are adding fractions, let's say for example 1 over 2, and we have plus 3 over 4. What do? You multiply this one by 2 over 2 so that you can get what? 2 over 4. And then say 2 over 4 plus 3 over 4 is equals to 5 over 4. You see that? So that's the same concept we are using. Same thing. Nothing has changed. Okay. So now let's add our things. So it's going to be what? It's going to be 3x minus 3. The denominator now is the same. Like here, you see I use 4, is 4, then the denominator is just one thing. So here we have x squared, x minus 3 squared as our denominator, and then x plus 3, something like that, okay? And then we just combine our numerators, plus 2x plus 3, okay? And then from there you can what? You can simplify your thing. Let's remove the brackets and all those things, so it becomes 3x. Take note, don't make mistakes. You see, I'm taking my time. Right, 3x minus 9 plus 2x, I'm hoping I'm not making mistakes, plus 6 over x minus 3 squared, and then x plus 3. You see that? And then you simplify your thing. I don't want to spend a lot of time on one thing. Then you can simplify that. You will get 5x minus 3 over the numerator there, because these are like terms, and then these also are like terms, okay? Right. Okay, it's not about getting the answer here, it's about learning the concepts that we're going to use in the examination. Remember that, okay? Right, I want us to try 133. How many points? 3 marks. So this, I'm going to give you 2 minutes to try 133. Let's try. Right, welcome back, grade 10s. I was trying to erase here so that we can work nicely on question 133. I think I managed that. Let's continue. What did you find out? Right, so remember the laws of exponents. Remember the laws of exponents, okay? If you are multiplying powers with the same base, what do we do? When you're multiplying powers with the same base, what do we do? We add the exponents. Remember that. So, yeah, you see now, this thing is giving me a problem now. Okay, let me see. Okay, right, I cannot continue without the pen, so I need my pen. Right, let's take a short break. Let's take a short break so that I can try to get my pen here. Okay, just a short break, get my pen, then we continue from there. Let's take a short break. Laws of exponents. Do you remember that? When we are multiplying powers with the same base, what do? We add the exponents. Remember that. We have x to the power a plus x to the power b. What am I saying plus now? Okay, I don't want to erase now because if I erase, my pen will disappear. Times, not plus. Right, x to the power a times x to the power b is equals to x to the power a plus b. When you're multiplying bases, powers with the same base, we add the exponents. Okay, so now learners, you should be able to move from this to this and from this to this. Usually we just move from this one to this one, and then we forget that we can move from this to this. We can break this power into two things. Okay, we're breaking the power, so we can do the same thing with this one here. Do you see that? So it is 3 to the power t. I'm not sure if the t is clear there. And then 3 to the power t minus 2 over 2 times. The dot there means times. Okay? Remember, times can be a dot, can be a bracket. Remember that. And then times. So 2 is the coefficient. It's not the base. 2 is the coefficient. Then 3 to the power t minus 3 to the power t. Now we can break this using this, moving from this to this. What does it become? It becomes 3 to the power t minus 3 to the power t times 3 to the power negative 2. You see that? Okay, dot means times. Over 2 times 3 to the power t minus 3 to the power t. It's a mark. You've done something. You deserve a mark for that. Okay? Now, what's the next step? Let's look at the numerator. How many terms do you see within the numerator there? Okay? It's one term. Remember, it's one term here. I understand that. But now, let's look at the numerator. There are two things. There are two terms in the numerator. And then there's something common. What is it? It is 3 to the power t is common. So we factor it out. Remember, grade 10s, when you're factoring out, you are not taking it out. Some people take the factor out, then it remains as nothing in the bracket. No. We are factoring out. So when you're doing that, we divide everything in the bracket by it. Okay? So you factor out 3 to the power t, and then what is 3 to the power t divided by 3 to the power t? Is 1. That's another common mistake. You find that people say, I've taken out 3 to the power t outside the bracket, so there's nothing now inside the bracket. No, that is a big mistake. If you have two terms and you factor the common factor out in the bracket, you must have two terms. You can't remain with one after factoring out. You must remain with two after factoring out. In the bracket, there must be two of them. Right, and then minus 3 to the power negative 2. And then again here, 3 to the power t is what? Is common. So we say 3 to the power t, and then we remain with 2 minus 1. Right, we've gained another mark. We've gained another mark there. We have done a lot. Okay? 3 to the power t divided by 3 to the power t is 1. Okay? I don't like saying cancelling, because sometimes people that cancelling, then things disappear. And then, because it's a problem sometimes, I've seen people there, 2 over 4, they say cancel, then they remain with the answer is equal to 2. Because they think that you have cancelled. You said 2 divided by 2 is 1. So if you are dividing things that are the same, you're getting 1, not 0. Okay? So 3 to the power t divided by 3 to the power t is 1. And then now we're remaining with 1 minus, what is 3 to the power negative 2? Remember, a to the power negative 1 is like 1 over a. Do you remember that? So this is like 1 over 3 squared over 2 minus 1. 2 minus 1 is 1. So you're basically remaining with this, which is 1 minus 1 over 9. Okay, what is 1 minus 1 over 9? Remember, 1 is like 9 over 9. Okay, so what do you remain with? Your answer will be 8 over 9. Okay, 8 over 9. Right, factorize fully. Okay, it says factorize fully. I'm going to explain these ones because we spent a lot of time on algebra so that you can move on to the next thing. But it's still okay. It's still okay. We still have about 1 hour and 20 minutes. So it's still okay. Right, but now let me explain this. I'll give you time to try other things out. What do you see here? Because sometimes as learners we get confused. We don't know the difference between what? Between expressions and equations. These are just expressions. Okay, we're factorizing them. Okay, I'll explain another common mistake when it comes to 113 there. Okay, so if you look at 111, it's a binomial. It's two terms. Do we have anything common? X can get into x squared. X can get into x. So x is the highest common factor. If you have terms that have exponents, they say the same base, the one with the lowest exponent is your highest common factor. Like let's say you are factorizing x cubed plus x squared. It means x squared is the highest common factor. If you have x to the power 4 plus x to the power 3 plus x to the power 1, which is x, your highest common factor there will be x. If it's 2, your highest common factor will be x squared. So the one with the lowest exponent is your highest common factor. So here we have x to the power 1, which is x. So we can factor out x. Don't make that mistake again, whereby when you're dividing x by x, then it disappears. Okay, you find people now, they factor out x, and then they say this is x, like this. And then this has disappeared because they're saying they've cancelled. No, that's a big mistake. So now we factor out x, and then what is x squared divided by x? You can use the laws of exponents. You can expand. Your x squared is x times x. Then x divided by x, you remain with x. You can use anything that you have learned in mathematics. X squared divided by x is x. Minus x divided by x is 1. Remember that. So you have 1. Do you see that? We had 2 terms when it started. We have 2 terms inside the bracket. Remember, but when you bracket something, it becomes 1 term. Okay? I hope you understand what I mean when I'm saying 2 terms inside the bracket. I'm not saying that that bracket is what? Is 2 terms. No, no. Please don't. Okay. Right. Now, let's go to the next one. How many terms do you see there? We know how to factorize trinomials. Remember trinomials, okay? But this one now has got 4 terms. So this could be factorizing by what? By grouping. You can group them according to what they have in common. And if you check here, they're sort of grouped for us. Because if you check the first 2 terms, there's something common there. What is it? 3x. And then if you look at this last pair there, there's something common there, which is 2m. And then the key, your first bracket must be the same as the second bracket. So let's factorize. Let's factor out 3x. So what is 3x squared divided by 3x? It is x. And then what is 3px divided by 3x? It is plus p. Now it means the second bracket must be x plus p. And then now how do we do that? We have negatives there, negative 2mx, negative 2mp there. So we can factor out negative 2m. Negative 2m, right? And then we remain with x plus p. Okay, you see that? And then this is a common bracket. We can factor it out. Then becomes x plus p. And then we say this divided by x plus p, we get 3x. And then we say this divided by x plus p, we get negative 2m. Okay, you see that? Some people say this bracket forms your first bracket, then you take this and this to form your second bracket, which is still fine. Okay, right, we have factorized fully. Right, let's go to the third one. Now, there's another problem here, a common mistake. We are factorizing. You are not solving an equation here. I'll show you what you must do if you're solving an equation. Right now, we are just factorizing here. Do we have the highest common factor? When you're factorizing great terms, you're going to be dealing with the what? Trinomials. The first thing you look for is the highest common factor. The 3 terms, do they have a highest common factor? Do they have a common factor? Yes, they have, which is 2. Do that factorization. Factor out the highest common factor. So it is 2p squared minus p minus 6. And then inside the bracket, we have the trinomial. We look for the factors of negative 6. That will give us negative 1. Because here there's a negative 1 here. Here. Right. What I do, I list the factors of what? Of 6. Which is 1, 2, 3, 6. 1 goes with 6. 2 goes with 3. You see, if you say 1 times 6, you get 6. 2 times 3, you get 6. Right. This negative sign tells me that the one factor is negative and the other factor is positive. Because I'm multiplying 2 factors and getting a negative answer. So it means the other one must be negative, the other one must be positive. And then this negative here, okay, it takes the sign of the bigger factor. Now, the other one is negative, the other one is positive. So the combination that can give me that is 6 and 1. If I say negative 6 plus 1, I get negative 5. You see, it takes the sign of the bigger factor. So here, we just say 2, and then we have, I'm not going to do the long, let me do the long way, it's fine. Right, it's going to be p squared, and then we replace negative p with 6p negative 6p plus 1, okay, or plus 1 negative 6p is still fine. And then plus 1p, let me write 1p plus the negative 6p minus 6, okay, right? But we know that when you get your factors, great tens, don't waste time, okay? You know that you're just going to get what? P, is it plus 1? Plus 1, and then p minus 6, okay, because our factors was minus negative 6 and plus 1. Now I'm showing you the long method, okay, right? Because sometimes you are forced to use the long method, especially if the coefficient of x squared is not 1. So now 2, and then we factor out p here, is going to be p plus 1, and then we factor out negative 6 here, is going to be p plus 1. Okay, and then there's a common bracket here, which is 2, and then p negative 6, and then p plus 1. It doesn't matter the order, ne? Okay, so we have got p minus 6 or p plus 1 or p plus 1, p minus 6, just the same thing. Right, you see the 2 is still there. The 2 is still there because we're just factorizing. If it was an equation, it was going to be something different. Okay, because if it's an equation, let me just show you. It's going to be 2p squared minus 2p minus 12 is equal to 0. Right, you see that? And then when you factorize, you can factorize and be factorize and then or divide everything by 2. But let's say, because we asked to factorize, ne? Right, let's factorize 2p squared minus p minus 6 is equal to 0. And then if you divide this by 2, divide this by 2, then that's when the 2 can disappear. If you are solving the equation, if you are just factorizing the expression, this 2 must appear, must be there. It mustn't disappear. Okay? Right. The next slide, I'm going to give you work to do. I want you to try things, not listening to me the rest of the lesson. Okay, we have done something similar to this. It's a good activity because we have done something similar to this. How many? Okay, it's 7 points. Let me give you 5 minutes. Let me give you 5 minutes. Okay, and then after that we just do them together, and then we will take our break, and then we move on to the continue after that. Now I'm giving you 5 minutes to try these two. Let's try. Welcome back, grade 10s. Did you manage to get your answers? Let's see. Right, what do we do with 2 to the power a plus 1? We break it. Right, so it becomes, we talked about this, isn't it? So it becomes 2 to the power a times 2 to the power 1. Okay, and then minus 2 to the power a times 2 to the power negative 1. We did something similar to this. And then over 2 to the power a. And then what do we do after that? Let's look at the numerator there. There's 2 to the power a, which is common, so we factor it out. So 2 to the power a, and then 2 to the power 1, which is 2, minus 2 to the power negative 1, and then over 2 to the power a. Then 2 to the power a divided by 2 to the power a, you're getting 1. Okay, do you see that? So we're remaining with 2 minus 2 to the power negative 1, which is like 2 minus 1 over 2. What is 2 minus half? You're remaining with 1.5, isn't it? Which is 3 over 2. You can use your calculator to do those calculations. You'll get your answer. Okay, that's the first part. And then 1 to 2. What do I see? If I look at this expression here, I see the sum of 2 cubes. I see somewhere where I can factor out 2. I see division. And I know division, I have to tip and times. Tip and times. So out of 4 here, I'm going to get a lot of marks before I do anything. That is mathematics. If you look at the whole expression like this, and then you're thinking, now what must I do? Look for those things, and you find that you will move smoothly. Okay? The mathematics is not in the answer, it's in the process. Now the different sum of 2 cubes there, we have to deal with it. Tip and timesing there, we have to do it. Factorizing there, we have to do it. That's where the marks are coming from. And then 3 out of 4, that is 75%. Okay, so now I can see the sum of 2 cubes here. I'm not going to re-explain that. I'll just write the answer here. So it's going to be x squared minus x plus 1. Right, and then x cubed plus 1 is going to be, so these will form my first bracket, x plus 1, that's the first bracket. Then the second bracket, I'm going to have this one give me x squared. I'm going to have this one give me 1 squared, which is 1. And then at the center, I'm going to have 1 times x, which is x. And then here is always positive. Now I've got 2 plus, this one must be negative. It's always opposite the what? The sign here. So I have factorized there. And then times. You see? Tip and times. Now this one goes up. This one goes down. So it's going to be, should I factorize it? Let me do that so that I don't waste time. So it becomes 2 outside, then x plus 1. I've factorized 2x plus 2. And then over 2x. Now, do we have something common? Remember, we can divide across a times. Right, if I have 3 over 9 times 18 over 4, I can say 9 into 9, 1, 9 into 18, 2. But if it was plus or minus, I can't do that. I can't do that, grade 10s. Okay, you can only do that if it's times. Okay, so here is times, so I can say x plus 1 divided by x plus 1 is 1. Disappears 1. 1 times 2 is 2. 100 times 1 is 100. If you're getting something multiplying by 1, it just disappears. You remain with that number. Okay, right. And then 2 into 2 is 1. Again, we remain with that. And then x squared minus x plus 1. And then x squared minus x plus 1 there, 1. So it's like here we have 1 over 1. You see that? And then what do you remain with? At the top, we only have 1. If you check there. Just imagine now when you say you're cancelling things and then you're not remaining with nothing. What are you going to say? What over what? You see that? So when you're dividing same things, you're getting 1, not 0. So in the denominator, we're just remaining with x. Be careful with that. So our answer is actually 1 over x. Does it make sense? All that expression, just 1 over x. It's equivalent to 1 over x. You see that? We have simplified something which looked complicated to just be becoming 1 over x. Okay, right. Now, let's move on. Now, this is an equation now. I'm going to explain these two. Okay, right, this is an equation now. Be careful, greatness. If we had x minus 1 is equal to 0, we're going to celebrate. Why are we going to celebrate? Because things have been, this equation has been what? Factorized for us. The zero principle. See, on the right hand side we have our 0. So we can say therefore x is equal to 0 or x minus 1 is equal to 0. Therefore x is equal to 0 or x is equal to 1. It was going to be very easy for us. And we're going to see maybe around 2 marks there. We're going to see that. But now check this one. It's 4 marks. It's 4 marks. So it means there's more to it. Look at the mark allocation cretins. It informs you. It gives you a lot of information. Mark allocation. You find yourself working a whole page, half a page for 2 marks, there's something wrong. And you find yourself writing one statement, one thing, one line, then it's for 6 marks, there's something wrong. Okay, so look at the mark allocation, it must guide you. 4 marks, there's something more we can do. This can't be just 4 marks. Okay, so now if there's no 0 here, there's no way we can just do a shortcut there. We have to come up with the standard form. Remember, standard form is ax squared plus bx plus c is equal to 0. That's the standard form. Okay, right, now what do we do? Distribute. Have we done something mathematical? Yes, we have done something mathematical. We've distributed correctly. It's a mark. Standard form. I bring this 20 this side. X squared minus x minus 20 is equal to 0. You see, we have the standard form. You will get marks for your standard form. Till you get to grade 12. Standard form is very, very important. Under algebra, under functions, standard form. You cannot solve a quadratic equation if it's not in standard form. Whether you're factorizing, whether you're completing the square, whether you're using the formula, grade 11 you're going to be using the formula, you have to make sure that go to grade 11 with this. You say, I cannot solve a what? A quadratic equation if it is not in standard form. Remember that. Now you're preparing for examinations. Remember that. Okay, what are the factors? Let's list our factors of 20. This informs us. One factor is going to be negative, the other factor is going to be positive. This informs us. The negative factor is going to be the bigger one. So 1 goes with 20. 2 goes with what? 10. 4 goes with 5. Do you have another? No. Okay. So now which combination can give us 1? It should be these ones. You see the difference there. The other one will be negative, the other one what? Positive. Which one should be negative? The bigger one. So 5 should be the negative one. So x minus 5, x plus 4 is equal to 0. So x is equal to 5 or x is equal to negative 4. You have solved your equation. Done. Let's go to the next one. I always say this. I'm sure also Memo say in the classroom there, they always give you something to do. I always say to my learners, if you see the denominator, to get rid of it, multiply by it. To get rid of the denominator, multiply by it. Okay, so now there's this denominator here. Multiply by that denominator. You can put this in the bracket, it's still fine, or you can multiply individually, it's still okay. So now we multiply by that, so it becomes 3x minus 2 over 2 times 2, okay, is equals to. We've multiplied the left hand side by 2. So we can't just multiply one side by 2 and leave the other side, because it's an equation. What you do on the left hand side, you must do on the right hand side. And then we must multiply this side also by 2. Okay? You see that? Okay? and then becomes 2 divided by 2 is 1. Then you remain with 3x minus 2 is equal to 2x plus 2. I just remove the bracket there. Let's collect the like terms. Transposing. Okay, right? Okay, this one must come this side. So it becomes 3x minus 2x, which is 1x. And then plus 2 is going to be 4. So x is equal to 4. Where is this plus 2 coming from? From here. Okay? Right. You've answered the question. I really hope you managed to get something from this. Let's continue with our lesson. But now, before we continue our lesson, I want us to have a short break. Just 5 minutes. Okay? You want to stand up and stretch yourself? It's okay. Yeah. Okay. It's a bit hot today. Let's do that. And then after 5 minutes, you come back and finish our lesson. Let's try. Welcome back, Cretans. I hope you enjoyed your break. Let's continue. We still have about 40 minutes. We can cover a lot of things. Right now, given this inequality, where m is a real number, how do we solve such a thing? Okay. Right, I'll try to explain this in two ways. Okay, I'll try to explain this in two ways. Okay, let's see. We have, let me start with this one. Okay, I can have this as one inequality. Okay, and then I can have this one as another inequality. Then I solve them separately. Okay, you can do that. So now we have minus 4 less than or equals to minus half m. And then you have minus half m greater than 5. And then you solve them separately. Okay, let's start with the first one. So now what do we do to get m? We have a denominator here. We have to multiply by it. I'm going to multiply by 2 intentionally because I want you to understand. Right, some people now say, where is the minus 2 coming from? Okay, let me start by multiplying by minus 2. But you can actually multiply by minus 2 both sides. So now I'll start by multiplying by minus 2, and then, sorry, by 2 only. And then you get negative 8 less than or equals to negative m. You see that? I've just multiplied times 2 this side times 2 this side. Okay? And then now you're dividing by what? Dividing by negative 1 because we want to get m. So you're dividing by negative 1. Negative 1 here, divide by negative 1 there. And then if you're dividing by negative 1, what do you get? The sign, inequality sign changes. So it becomes greater than or equals to. So it becomes 8 greater than or equals to m because of the dividing by negative. Okay? Right. Now, it means m is less than or equals to 8. This. Or 8 is greater than or equals to m. Does it make sense? Let's take, for example, 2 and 3. 2 is greater than 3. Meaning that 3 is less, what did I say? 2 is less than 3. Okay? 2 is less than 3. Meaning that 3 is greater than 2. Okay? Let me write it. 2 is less than 3, like that. 2, if you are reading going this way, 2 is less than 3. When you're going this way, 3 is greater than 2. So it's the same thing here. We're saying m is less than or equals to 8. So it can be 8, 7 going downwards. Okay? It's a real number, so it can be a fraction also, a decimal. Right, then we come to this side. Okay? Let's multiply. Let me also multiply by 2. Okay? First. Because we can also multiply by negative 2 once. But let's multiply by 2. You'll get negative m less than 10. I've just multiplied by 2. I said times 2 times 2. Okay? Now let me divide by negative 1. Divide by negative 1. Divide by negative 1. So it means m is greater than negative 10. You see that? Why did it change? Because I divided by the negative 1. So if you divide by negative 1, this inequality sign changes. So now we're saying m is less than or equals to 8. But it is greater than negative 10. You see that this is an interval. Negative 10, there's negative 10 here. And then there's what? There's 8 here. So m is greater than negative 10, but less than 8. No, this one is less than here. Okay, you see that? It's an interval. M. So here, when you're writing this solution, you say m is less than or equal to 8, and because it is an interval. Right. And then, now, okay, we've done this, which is solving for m. And then write the answer to question 2 as an interval notation. That's what we've done actually here. We have written our answer in what? In the interval notation. Okay? We have written our answer in the what? Interval notation. Right, now, and then it can be represented like this also. Right, m, it means what? M is greater than negative 10. So it's going to be m here is element of what? Is negative 10 included? Okay, not included. So we use a smooth bracket and then negative 10. And then 8, is 8 included? Yes, it is included. And then up to 8 included like that. Okay, you can write it like that also. Okay, right. And then let's go to 2.3. I want to give you 2 minutes. It's 2 marks. You see, the questions that were 2 marks, I was giving you 1 minute. Okay, but now this one I want to give you 2 minutes. I want you to try question 231. It will be very, very interesting if you get it. It's a nice question. Okay, and then after 2 minutes we're going to what? We're going to do it together. Let's try. Right, welcome back, greetings. Did we manage to get the 2 marks? Yes, this question is 2 marks, but I think it deserves more marks because it's a bit challenging, I think. Okay, right, what did you do? What did you do? Right, now, if you check here, we have the difference of 2 squares. Did you see that? So this is actually 2x minus y, and then 2x plus y is equals to 171. So that is this equation here. See that? Okay, and then the question says find 2x plus y, and then 2x minus y we're given 2x minus y. That 2x minus y is 9. So actually this is 9, and then 2x plus y is equal to 171. And then what do we do to get 2x plus y? We divide by 9 both sides. Divide by 9, divide by 9. Okay, so what is 171 divided by 9? Let me check my calculator. 171 divided by 9. Right, 19. Okay, perfect. So 2x plus y is equals to 19. See that? Yeah, it was 2 marks, but it was a bit challenging. Right, but it's fine. It was very, very interesting at the same time. That's the good thing about mathematics. You must enjoy mathematics, okay? And then it will be going to be friendly for you, to you. All right, solve simultaneously now. Okay, now we can solve our simultaneous equation. Right, we already know here we can create our equation number 3. Okay, which is I can bring this y this side and bring this 9 this side. So it means 2x minus 9 is equal to y. Then that's equation number 3. Okay, this is equation number 2. This is equation number 1. Then where there's y, I can take this thing and then put it here where there's y here, and then I solve for x. That's how you solve simultaneous equation. What? By substitution. So it becomes 4x squared minus 2x minus 9 squared is equals to 171. Okay, right, and then expand your things. This one is not difficult, but you're doing a lot of things and you can make mistakes. So try to be accurate when you're doing these things so that you don't make mistakes. So it becomes 4x squared minus, usually sometimes I use square brackets to assist me, and then sometimes when it's 2x minus 9 squared like that, it confuses me. Okay, so I will write it as 2x minus 9, then 2x minus 9, okay, like that, and then close my square bracket is equal to 171. We may be doing things differently, okay, it's okay, but let's make sure that we do what? We do the right thing. And then I work within the square bracket. Okay, I work within the square bracket so that I get this 4x squared minus my square bracket. What is 2x? I can now put my arrows here, my arrows there, my arrows there. 2x times 2x is 4x squared. May look complicated. May find that we're going to get a very simple equation. Right, 2x times negative 9 is negative 18x. And then negative 9 times 2x, negative 18x. There are other ways of expanding this, which is very fast. But if you're having problems, just stick to this. And then negative 9 times negative 9 is plus positive 81. Okay? Then let me bring this 171 this side so that I have my standard form. So it becomes minus 171 is equal to 0. Right, I want to see if I'm doing the right thing here. So it becomes what? And then if you simplify things, it becomes 4x squared minus 4x squared. What do you see there? It means the 4x squared is going to disappear. 4x squared minus 4x squared is 0. And then minus 36. Is it 36? Yes. 36x. No. I'm making a mistake here. I'm distributing the negative here. I'm distributing the negative. So it's going to be plus 36 and then minus 81. And then now take note of the signs. We're distributing negative, so the signs are going to change. Right, and then minus 171, okay, which is equals to 0. And then we get 36x, right, minus 252 is equal to 0. Do you see that it's becoming a linear equation? And then you may say 36x is equal to 252. Divide by 36 both sides, you get that x is equal to 7. See that? And then you can take your 7, this, and put it there, which is 2 times 7, which is 14. And then, what is 14 minus 9? 14 minus 9, it's funny, I just forgot that. Is it 5? 5, yes, makes sense. Right, okay, so and then you get your y. Remember, when you're solving simultaneously, you must get what? Your x value and your y value. Okay, don't forget that. Okay, right, now let's move on. Given is another inequality. Given 4 minus 2x less than 16, where x is a real number, right, solve the inequality, hence represent your answer in question 211 on a number line. I didn't change the numbers on our questions so that I know when I say refer to this question, like these are questions from past examination questions, né? So they mustn't confuse you. Okay, our fourth question may be the second question from another paper, so that must not confuse you, learners. Right, okay, now I want you to try this question for 2 minutes. Two of them, 211 and 212 is for 2 minutes. Let's try the questions. Right, welcome back, greetings. Let's continue with our lesson. Okay, right. Now, after this question, I will go to the last questions on algebra so that we can also cover number patterns. Okay, right. We've done inequalities, and then now we must understand. So let's start with this one. 4 minus 2x less than 16. Right, what we do, we solve the same way we solve what equations. Okay, right, and then you can transpose them, becomes negative 2x less than what? Less than 12. Is it? Yes, 12. Okay, 16 minus 4, that's 12. And then we divide by negative 2 both sides. When you divide by negative, what happens? You see, they like this sort of question where the inequality sign changes. You see that? Please take note of that. And then these are different past examination questions. Anyways, we continue seeing this. Okay, so we divide by negative 2, then the sign changes, becomes x greater than negative 6. You see that because we're dividing by negative 2. And then represent this on a number line. So it means this is a number line, and then this is 6 here. Okay, you don't need to draw a complicated one. And then is 6 included? No. X should be greater than negative 6. Greater than, if I say greater than or equals to, then means 6 is included. Okay, in real life I say, I want 2 learners to come to the front. 2 learners or more to come to the front. It means I must have 2 learners or more. If I want more than 2 learners, it means more than 2 learners must come, means 3 and on, and what? And higher than 3, like that. Okay, so now when you're saying greater than negative 6, it must be greater than negative 6. So 6 is not included. So we use an open circle. Okay, and then greater than 6. If it was like this, x greater than or equals to negative 6, then we're going to shade our circle. We're going to shade it and draw it like that. Okay, take note of that. You get such questions in the examinations. Right. Simultaneous, we've done simultaneous, we've done this concept. No, I want us to do this one. Okay, we've done this concept. Let's leave it, and then let's do this one. Literal equations. Solve for x. This one. Okay. Now, someone will ask, now, how do I solve for x here? They're just letters only. C, A, 2. What is that? How do I solve for x? It means make x the subject of the formula. Great tense. Okay. Let's get rid of everything that is attached to x. We're just doing the inverse. Inverse. The opposite. Inverse means opposite. Okay? Right. There's something that is attached to x here that we can get rid of it. The first thing you have to check, the root sign, the square root sign. What is the opposite of square root? What is the opposite of square root? Is squaring. The opposite of cube root is cube root, cubing, you cube. Okay, square root, you square. Now, let's square both sides. What you do on the left, you do on the right. Right, so it's going to be c squared is equal to square root of a plus 2x squared. And we know that the square root and the square, they cancel each other out. If I square root 2 squared, I get 2, isn't it? Okay, so I say square root of 2 squared is equal to 2, because square, what am I writing? Is equal to 2, because, so the square root and the square, they cancel each other out. So now we remain with c squared is equals to a plus 2x. Now we still have something attached to x. We want x to be the subject. So there's this a here, this a. How do we get rid of the a? Remember, we did additive inverses. So we subtract a both sides. We subtract a both sides. Or let's use the one method that we're using now, which is transposing. So we bring this a this side. It becomes c squared minus a is equal to 2x. Still, there's something attached to x. What is that? It's 2. What is the operation between 2 and x? Is multiplication. What is the inverse of multiplication? It is division. So let's divide both sides by 2. To get rid of something, do its inverse. If it's addition, do the additive inverse. If it's multiplication, do the multiplicative inverse. So here we're going to divide by 2 both sides. or multiply by half. So you divide by 2, then 2 divided by 2 is 1. So therefore x is equals to c squared minus a over 2. Done. Please take note of this. Right, you can write the question, try it on your own after this lesson. Okay? Right. Now, it's another common question when it comes to grade 10s. Right. Tabelo is currently 4 times as old as his daughter. Sometimes I try to put these things in real life situations. Okay? And then it assists me a lot. Okay? Daughter Linda, 6 years from now, Tabelo will be 3 times as old as Linda. Okay, for uniformity, let's make Tabelo's what? Age be x. And then Linda to be y. Right, I'm trying to put this thing into a real life situation. Right, okay? Yeah, you're learners now. You can put yourself as the daughter, okay? And then like that. You can, either way, it is going to work out. Right, now I have my daughter and I'm thinking right, now I'm 4 times as old as my daughter. It means I have to multiply my age. I have to multiply my daughter's age by 4 to get mine. If my daughter is 10 years, then it means I'm 40 years old. You see that? So if my daughter is y years, it means I'm 4 times y. So my age is 4 times that of my daughter. So my daughter's age is what? Is y. And my age is x. So I'm going to say my age, which is x, is equal to 4 times y. So now Tabelo's age is 4 times the daughter's age. That gives us the first equation. Okay? Which is x is equals to 4y. We have used this statement. You see that? We have created an equation using that statement. We go to the next statement. 6 years from now. Okay, what is going to be my age in 6 years' time? It's going to be x plus y. 6 years from now. It's going to be x plus y. What about Linda? It's going to be what? Y plus what is it? X plus y, guys. Right, I made a mistake here. So 6 years from now, Tabelo will be 3 times as old as Linda. So we're going to add what? We're going to add 6 years on our age. No, so it's not going to be x plus y, but it's what? It's x plus what? Plus 6. Okay, it's going to be x plus 6. And then to the Linda's age is going to be y plus 6. Okay, the Linda's age is going to be y plus 6. But remember that, okay, my age is going to be what? 3 times that of what? Of Linda. And my age is 4 times y. X is 4y. X is 4y. Okay, so now we have to create another equation. So it means 4y plus 6. This is my age now. And then I'm adding 6 years. It's going to be 3 times y plus 6. Okay? 3 times y plus 6. Y plus 6 is the age of Linda now. Y is the age of Linda now. And then in 6 years' time, it's going to be y plus 6. Okay? My age is 4y now. And then in 6 years' time, it's going to be 4y plus 6. Does it make sense? Okay, let me try to explain again. Maybe I didn't explain it nicely. Tabelo is currently 4 times as old as his daughter. 4 times as old as his daughter. Right, like for me, for example, let's put me. Right, now my age is going to be 4 times that of my daughter. So it means if my daughter's age is y, my age is 4 times y. Okay? And then in 6 years' time, my age is going to be 4y plus 6. Okay? And then my daughter's age is going to be y plus 6. But my age will be 3 times this age. And then we've created 2 equations. Equation number 1 and equation number 2. And then we can solve these equations simultaneously. Okay, right, let's simplify this equation. 4y plus 6 is equal to 3y plus what? 18. Okay, and then where there's x, oh, here we can solve for y. We can solve for y, right? Let's say 4 minus 3 is 1y, and then I brought this 3 this side, I brought this 6 this side, and then 18 minus 6 is 12, okay? And then where there's y, we put 12. So it's going to be x is equals to 48. Y is equals to 12. Let's see if our answer is correct. Right, what is 12 times 4? It is 48. You see that? So currently, my age is 4 times that of my daughter. And then what about in 6 years' time? Let's add 6 here. Let's add 6 here. It's going to be 50. 6 plus 48 is 54. And then 12 plus 18 is 12 plus 6 is 18. And then 18 times 3 is 54. Do you see that? In 6 years' time, it will be 3 times that of my daughter. You see that? Something like that. So it may be difficult, but if you try to put it in real life situation, it helps sometimes. It helps sometimes a lot. Okay, let's try. Now, I want us to go to the last part of our lesson, which is what? Sequences. Okay, in grade 10, usually deal with what? With linear sequences. Okay, right. Dark tiles, D, and light tiles, L, are used to create patterns on a floor. The first 4 patterns are shown below. For the patterns that follow, the tiles are arranged in a similar manner. Okay, so I'm going to explain everything now because we're left with 15 minutes. Okay, right. How many dark tiles were used in pattern number 5? Okay, right. Check the dark tiles and see if there's a sequence that is formed. Pattern number 1, how many dark tiles we have there? 1. Pattern number 2, how many? 3. Pattern number 3, how many? 1, 2, 3, 4, 5. 5. Pattern number 4, how many? 1, 2, 3, 4, 5, 6, 7. 7. Okay, so this is pattern number 1, pattern number 2, pattern number 3, pattern number 4. How many tiles with pattern number 5? What is it going to be? 9. Do you see that? The difference here is 2, 2, 2, 2. You see that? So the pattern number 5 will have 9 of them. Okay? 1 mark. Gain that mark. Is very, very important. Right? How many light tiles were used in pattern number 6? Okay? How many light tiles were used in pattern number 6? Again, do the same thing. You do the same thing. Okay? So here is 0. Here is 1. Is 1, 2, 3, 4. 4. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. It's an interesting pattern that we see here. What type of patterns do you see here? Is what is actually a square numbers, except 0 here. See that? 1 is a square number. 4 is a square number. 9 is a square number. So the 6th one, this is 1, 2, 3, 4. So the 5th one is going to be 25. And then the 6th one is going to be 36. You see that? Because we're talking about square numbers. After 9, what did I say? The 6th one, we have 1, 2, 3, 4. And then after 9 is 16. Okay, not 20. And then 25. You see that? So it means the 6th one is going to be 25. This one will be the 5th one. Then this one will be the 6th one. Okay? So you can even write your numbers like that and gain this mark. Very easy. Okay? Right. Now, write down the general term for Dn for the number of dark floor tiles used in each pattern. Right, I want us to go, we'll go to the last question, which involves everything that must be calculated in what? In a sequence, where you find n, where you find Tn and all that. So I'll just shift to the last question because I left with about 13 minutes, okay? Let's just go to that question, then we do everything together, and then we're done this question, okay? So we're going to do this question together. This is a typical examination question, okay? You see, you find the missing term, you find the nth term, you calculate the value of the 15th term, and then which term in the sequence is 83. So once we've covered this question, we've covered a lot of things under what? Under sequences. Right. Consider the linear sequence 5, 8, 11, B, 17. Right, check if there's a common difference, okay? Right, so here, the common difference, 8 minus 5. Remember, say term 2 minus term 1 is 3. 11 minus 8 is 3. So it means now B minus 11 must be 3. So you must add 3 to 11 to get B. So what is B? What is it? It's going to be 14. And then 17 minus 14 is 3. So the common difference here is 3. Okay, so it means B is equals to 14. We've got 2 marks. It's a lot of marks. Determine the nth term of the sequence. What do they mean by that? That's your general term. Okay, that's your general term. That's your nth term. That's your Tn. And then for a linear sequence, you start with this. Tn is equal to An plus B. Always start with that. And then what is A? This is your common difference. Okay, that's your common difference. So you substitute your common difference and then you solve for B. Then you're done. Okay, so let's do it. So it's going to be Tn is equal to, what is the common difference is 3. You see the 3 there. So it's 3n plus B. Now you can substitute any term you want. But why choose term 3 if you can use term 1, which is what? Which is in a smaller number. Let's use term 1 and see what you're going to get. We're just going to use 2 terms to just see that you can get with any term. So T1 is 5. So where there's Tn, put 5. Tn, I said, is the term in the sequence. So 5 is equal to 3n plus B. And then our n is what? 5 is first term. So it means n is 1. And then what is B? You say 5 minus 3 is equal to B. So it means B is equal to 2. So therefore Tn is equal to 3n plus 2. Does it make sense? So if it's 1, you say 3 times 1 plus 2 is 5. 3 times 2 plus 2 is 6. 3 times 3 plus 2 is what? 11. You see that? Okay, right. Even if you chose 8, you can say 8 is equals to 3, but now 2 because 8 is term number 2. Then plus B. And then it's going to be 8 is equal to 6 plus B. And then 2 is equal to B. Still, you're going to get the same answer. Do you see that? You can choose any term. Right. The other one that you used at when you're doing grade 8 and 9, you can say, right, your T1, okay, what is it? You say 3 times 1, the common difference. And then what do we do to 3 to get 5? We say plus 2. Then you go to T2, which is 3 times 2. Then what do we do to 6 to get 8? We say plus 2. Then T3, you say 3 times 3. Then what do you do to 9 to get 11? You get 2 times. And then that. Therefore, Tn is equal to 3n plus 2. You see that? We used to do that in grade 9. Okay? But now, grade 10, you can use that with this. Your A is your common difference. And then you can use your equation to find what? To find the constant B. Right. That is finding the Tn. Calculate the nth. Let me change color. I don't want to change the eraser because sometimes after using the eraser, then things don't. Yeah, my color has changed. Right now, calculate the value of the 15th term of the sequence. Now we have our general term. Tn is equal to 3n plus 2. So actually here, what are we finding? When you're saying calculate the 15th term, it means we're finding what? We're finding T15. Where there's n, you see, there was n here, now I put 15. So where there's n, you put what? You put 15. So it's going to be 3, 15 plus 2. What is 3 times 15 is 45. 45 plus 2, 47. So it means there will be what? Calculate the value of the 15th term of the sequence. So it means the 15th term, T15, is 47. So 47 is T15, is the term in the sequence. And then n is 15. So the difference between Tn and n there. Let's take note of that. Which term in the sequence is equals to 83? What are we looking for? Are we looking for Tn? Are we looking for n? What is 83? Right, 83 is the term in the sequence. 83 is the term in the sequence. So now, where we have our, Let me use another color. Right, so we have our Tn is equal to 3n plus 2. So our 83 is the term, which is 83. We're looking for n, so that we know what 83 is term number what. So it's 3n plus 2. Transpose. What is 83 minus 2 is 81, is equals to 3n. Right, and then divide by 3 both sides, divide by 3, okay? And then we get what? We get 3 divided by 3 is 1, so n is equals to, what is 3 into 6? Should be 27, né? Let me just confirm that. 81 divided by 3, 27, yes, okay? So it's term number 27. I'm very, very happy. I'm very, very happy. Why? Because the chances of this answer to be correct are very high. They have seen some people that you are calculating for n, and then you get 2,5, and then you continue. It's impossible. N is term number. You can't get a n which is a fraction or decimal, or it's negative. No, you can't. It must be a positive integer. Okay, so now, so it means n is 27 there. Please take note of that. N is always what? A positive integer. From 1 can be term number 1, can be term number 2, can be term number 3. It can't be term number 4.5. No, it can't be. Okay, so always get what? If you get 2 answers, choose the one with what? With positive, which is the positive integer. Okay, right. Let me see if we can go back and do a few. Now this one I got. Okay, we did this one. Right. Right, let's look at the light touch. We were done with all those concepts there, and then we want to go back. I'm just going back because we're left with 5 minutes. Okay, right, let's just do, we had a sequence like 0, 1, 4, and then 9, and then we discovered here that this one is the square number, so there must be a square somewhere. Okay, so now 0 would be 1 minus 1 squared, that's 0. Here you say 2 minus 1 squared. Okay, what is 2 minus 1? It's 1, isn't it? 1 squared is 1. Then what is 3 minus 1? It's 2, isn't it? 2 squared is 4. And then what is 4 minus 1 is 3. And then 3 squared is what? Is 9. Do you see that? So the general term here is actually n minus 1 squared. Okay, right. The first one, 1 minus 1 is 0. And then 0 squared is 0. And then 2 minus 1, which is 1. 1 squared is 1. Then 3 minus 1 is 2. 2 squared is 4. Then 4 minus 3 is 1. 4 minus 1 is 3. 3 squared is 9. Something like that. So this is the general term, which you can get by what? By observing this. Okay? Because we can't do quadratic sequences now. You'll do them in grade what? In grade 11. Now you are just observing and trying to come up with what? With the general term. Right. Okay. Now this is our general term. And then which pattern will have exactly 64 floor tiles? Okay, let me try to do this one first. We got that our Tn is equals to n minus 1 squared. You see that? So now which pattern will have 64 tiles? So what is 64 here? Is it n or Tn? It is Tn, isn't it? So we're saying 64 is equals to n minus 1 squared. And then what is n? We have to solve for n. So we're saying 64 is equals to n minus 1 times n minus 1. I usually do this, but you can do without this. Because I'm explaining, so I try to make sure that I do all the steps. So 64 is equal to n times n. Draw your arrows. For using foil, you can do that. N squared minus n plus 1. Okay, so which is 64 is equal to n squared minus 2n plus 1. Right, what do we do here? What do we do, cretins? What must we do? Standard form. So we're going to bring this 64 this side. It becomes n squared minus 2n minus 63. Okay, because 1 minus 64 is what? Is minus 63. Okay, right. Now, which factors can give us minus 2? It should be 9 and 7. 9 times 7 is what? 63. Right, so it means, and then the other one must be negative, the other one must be positive from here, and then the bigger one must be what? Must be negative. So it means 0 is equals to, this is also standard, right, guys? Great, like 0 is equals to ax squared plus bx plus c. It's just the same thing as ax squared plus bx plus c. Okay, so is equal to 0. So it's just the same thing. Okay, right, now we solve. So it's got negative 9 and plus 7. So it's n minus 9 and then n plus 7. Okay, therefore n is equal to 9 or n is equal to negative 7. So what is our answer here? It is this. We can't have term number which is negative, so this is not applicable. Okay, we discard it, we throw it away, and then we remain with this. Okay, so when you get answers which are negative or fractions when you're calculating for n, you discard them, okay, and get positive integers. Okay, I really hope that you managed to learn something, grade 10s. Right, we did a lot of algebra, and then we rushed through what we call this number patterns, and then remember we did functions a lot in the other previous lessons, and then now you should be ready for the examinations. I wish you all the best. I wish you all the best. Let's try, and then remember to sanitize, to social distance, and to wear your mask, and take care of each other. Let's meet again in our next lessons. Thank you very much. Enjoy.